three possibilities where we may need to find the distance between points on a coordinate plane. The distance between vertical and horizontal pairs of points are trivial. Why are they trivial? Like, for instance, if I had a point here and a point here, would I be able to find the distance pretty easy? Yeah, what is it? Huh? What is the distance there? 1, 2, 3, 4. You can count it, right? That's why I'm saying it's trivial. Same with if I went from here to here. Do you see? Horizontally, it would be trivial. However, going this way, not trivial. So, how do you think I would be able to, well, actually, maybe I'll finish the 2 blanks here. We can simply find the difference between the 2 points or count, right? Like, for instance, I just went 1, 2, 3, 4. However, if this is a height of 6 and a height of 2, do you see if I take the difference between 6 and 2, I get 4? Same with here. If this is -5 and -2, do you see the distance between -5 and -2 is 3? Okay. So how would I figure out this right here, this length right here? Yeah, it actually, the distance between points has to do with Pythagorean theorem. So does everybody see, this is a 3, 4, 5 triangle here. This distance is that. So you can't actually count the diagonals, go, oh, there's 1, there's 2. You're not counting full lengths. The length of the square is you know, that length. You could probably approximate by going, oh, there's 5 of them. But there's an actual formula for that, and it comes from a squared plus b squared equals c squared. So first off, we're going to find the distance between A, which is -3, 7, which is 1, 2, 3, 4, 5, 6, 7. There's my A. And B, which is 6, 7. Okay. So it's saying if they're a horizontal or a vertical line, all you have to do is find the difference between the two. So does everybody see, if I take 6 and subtract -3, what do I get? 9. What happens if I count it on the thing here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you see it's a distance of 9? Pretty easy, yeah. Now we're going to do C and D, which is 6, -4. 1, 2, 3, 4, that's C. And D is 6, 6. So again, vertically, all I have to do is find the difference between -4 and 6, and what would that be? It would be 10. Again, I can also count it, but if you don't have a graph to count it, you can just find the difference. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Does everybody see that? Okay. So vertically and horizontally, very easy. So when a line segment is diagonal, you're not able to just count the distance. Based on the Pythagorean theorem, we're able to determine the diagonal distance between 2 points using essentially the distance formula. Does this ring a bell here? Remember, a squared plus b squared equals c squared. If I wanted to actually solve for c, do you see that c is the square root of a squared plus b squared? That's where this is coming from, right? And so the a is the difference horizontally, and b is the vertical distance. And that's the differences here. So do you see? The difference between the two and the difference between the two. That's where this is coming from. Okay, so find the distance between -7, 5, and 4, -3. So if we're going to just do a pure substitute into the distance formula, x1 y1 will be the first point. This rings a bell from what formula for labeling x1 and y1? The slope, yeah. And so this becomes x2, y2. Yes? And so now we're just going to substitute it in. D equals the square root of x. I'm going to write out the formula. How about that? x2 minus x1 squared plus y2 minus y1 squared. So x2 was 4. So 4 subtract negative 7. So that's 4 plus 7, yes. Plus y2 is negative 3, and then I'm subtracting 5, and we're squaring it. So what's 4 plus 7? 11. So this is going to be the square root of 11 squared plus, what's negative 5 subtract, sorry, negative 3 subtract negative 5. Sorry, negative 3 subtract 5. Negative 8 squared. So this is the square root of 121 plus 64. Does everybody realize when I square things, it's always going to be positive? So don't ever do a subtraction in there, because when you're squaring the two separate, no matter if this is negative, it's going to be positive. So you're going to be adding this stuff in between. So we get, what is that? 185. This is a good review for radicals units. So what did we do when we had the square root of 185 there? Yeah, you start doing a rapid divide to see if there's any perfect squares that go in there. So 185, it ends in a 5, so 5 must go into there. What? 37. Is 37 prime? What will go into 37? Yeah, so we're going to leave ours as radicals. We're not going to actually get the distance. However, just for fun, though, we're going to do a quick sketch here just so you can see. So the first point was negative 7, 5. So here's negative 7, 5. And the second point was 4, negative 3. So 4, negative 3, say there. You see, we're trying to find this distance. So essentially what we did here is we created a triangle, a right triangle. Do you see? And so the length between here and here was the difference, or the distance, I should say, from what to what? I'm sorry? Yeah, x1 to x2. So what was that? It was 11, right? And then this length here was the distance between y1 and y2. And what was that? 8. You see? Do you see how we're getting the square root of 185 now? Because you've done that so many times in grade 9, right? Pythagorean Theorem. So I guess what I'm trying to say to you, if you ever forget how to do the distance formula, you could do a rough sketch and do Pythagorean Theorem, right? So it's just faster if you know the formula. Okay, so let's find the distance between negative 12, 15, and 8, 3 using the distance formula. So x1, y1, x2, y2. Everybody good? And we're going to plug her in. D equals the square root of 8 subtract negative 12. So 8 plus 12 squared plus 3 minus 15 squared. Does everybody know where I'm doing this? Yes? So this is the square root of 20 squared plus negative 12 squared. Yes? What's 20 squared? 400. What's 144? Very good. So then this is the square root of 544. you want to estimate what that is roughly? Do you remember how to estimate square roots? This is good review. Well, 25 would be what? 25 would be 625. 24 would be 24 is too much as well, actually. Yeah, so it's going to be roughly 23 points something or other. It's 625. Okay, it says here a quadrilateral has vertices PQRS. Find the lengths of the diagonals to the nearest tenth. So let's draw this. So 3, 5. 1, 2, 3, 4, 5. That's P. Negative 4, 3. 1, 2, 3. That's Q. And then negative 3, negative 2. So that's R. And S is 5, negative 4. And then we're going to connect the dots. I'm going to use a ruler. Okay, so some quadrilateral of some sort. It's actually saying it wants to know the vertices, sorry, the lengths of the diagonals. Do you know what a diagonal is? So I guess what I'm saying is, am I trying to find the length from Q to P? Yes, Q to S is what I'm trying to find. So I'm going to do a different color. We're doing from, how come this didn't change color? I'll do the green. And then, ooh, look at that, eh? Okay, so this is what we're trying to find here. Does anybody know why I would try to find diagonals of a quadrilateral? Huh? You get the angles? Do you know any properties of quadrilaterals? There is a property of a certain quadrilateral. If the diagonals are the same, then it's rhombus. Okay, so I can tell by just looking at this, this is not a rhombus, because actually a rhombus. Okay, it looks like a trapezoid, but but what's the true about a trapezoid? Two sides are parallel. And the only ones that look like they could be parallel is QR and PS, and I don't think the slopes are the same. Are they? 1, 2, 3, 4, 5, 6, 7, 8. 8 over 2, and this is, so that's about 4. 1, 2, 3, 4. Yeah, the slopes aren't the same, so this is just some crazy quadrilateral. Okay, so we're going to find QS. So that is going to be the square root of the difference between the x's. So you don't actually have to plug it in. You could just look at what's the difference between negative 4 and 5. What's the difference between those? It's 9, right? So 9 squared. And what's the difference between, where is it? 3 and negative 4? 7. Okay, so the reason why it works this way, and it doesn't matter the signs, because in a second we're going to square it and it would be positive anyways. Does that make a difference? So it doesn't matter in the distance formula which way I'm subtracting. So square root of 81 plus 49, so this is the square root of 130. Okay, let's see if we can estimate that just for fun. No, on the test and the quiz, you're going to leave it as a radical. Okay? But this was something that was in another unit, right? So we might as well practice. 130, what's that roughly, Jackson? Okay, so what's the nearest perfect square to this? 11 and 12, right? So it has to be between 11 and 12. So what's this roughly? 11.4? Sure. Okay, so now we're going to do RP. So I'm going to give you a second to do that one. Okay, so the distance between R and P, so that would be the distance between 3 and 3 makes 6 squared, and the distance between -2 and 5 would be 7 squared. So that would be the square root of 36 plus 49. So that is what? The square root of 7085. So that is 9.2? 9.3. Okay. And that would be units, I guess, if we're going to put. Okay, any questions on that?